Good morning. We are starting section 2.3 in calculus today, and that is the first part of 2.3 is called the product rule, which is how to take the derivative of a product. If a function is one function times another function, this is how you'll take the derivative. So here's what's tempting. This is absolutely wrong, but it's tempting. If y equals x plus 3 times 4x squared minus 7. What you cannot do, you cannot just take the derivative of the first times the derivative of the second. Like, that is absolutely tempting, but it is absolutely wrong. When we learn rules of derivative, we learn that the derivative of a sum is the sum of the derivatives. And we learned that the derivative of a difference is the difference of the derivatives. That does not work with products and quotients. There's a different, special, unique formula for taking the derivative of a product. And it is one of these things that you will absolutely have to know, and you'll do it enough that you'll kind of have no choice but to know. So here's the actual rule, and it sounds more confusing than it is. And again, my picture is in it. It says the product of two different differentiable functions is itself differentiable. So if f has a derivative and g has a derivative, so does f times g. And the derivative of the product f of x times g of x is the first function times the derivative of the second function plus the second function times the derivative of the first function. And that phrase right there is something that I am telling you you should memorize. The product rule is the first times the derivative of the second plus the second times the derivative of the first. And I would literally say that to yourself enough times that it sticks in your brain. Product rule, the first times the derivative of the second plus the second times the derivative of the first. And here it is below that as kind of an equation. Hoping this makes sense. This says the derivative, just looking at the parts of the derivative of f of x times g of x, there's my product, is the first f of x unchanged times the derivative of the second, that's g prime of x, plus the second, which is g of x, again unchanged, times the derivative of the first. Another way to think of it is just f g prime plus g f prime. That's another great thing, kind of like a little phrase to have stuck in your head. First times the derivative of the second plus the second times the derivative of the first. Now, of course, f and g can be any letters at all. The functions might be h of x and q of x, so you just got to be careful what you're calling what. So when you notice that a function is a product of two functions, you need to think of the product rule. Now, we're going to do a few examples. And like several other derivatives we've taken already this year, always be on the lookout for, hey, before I take the derivative, could I rewrite the function more simply first? Would that make it an easier derivative to take? So this first example, we actually could do two ways. We can use the product rule, or we can simplify. So the function says f of x equals 5x times x squared plus 7. That is clearly a product. We have the first 5x. And what I often do when I see a product, I will, like, there's my first and there's my second. So let's actually do this using the product rule. And after we do that, I'll show you, whoa, I'm not sure what's happened there. I wanted to go there and I want to go there. Okay, so product rule says it's first times the derivative of the second plus second times the derivative of the first. I'm saying that phrase a lot during this video just to get it already stuck in your head. So this would be the first, which is just that 5x unchanged. And I'll put everything in parentheses here. Times the derivative of the second. The derivative of x squared plus 7 is just 2x. You knew that already. Plus the second unchanged. That's my x squared plus 7. Times the derivative of the first. And the derivative of 5x is just 5. So there, I used the product rule. First times the derivative of the second plus the second times the derivative of the first. Now, depending on what your first and second are, oftentimes this derivative is simplifiable, and you can make it look a little cleaner like that. In this case, I will just multiply this out. In standard forms, it's just a polynomial. 5x times 2x is 10x squared. And then here I have a distributive property, 5 times x squared is what, 5x squared? What's it, 5x squared? And then 5 times 7 is 35. I have like terms. I end up with 15x squared plus 35. There's that derivative. Perfect. Nothing wrong with using the product rule in that example. The next few examples, we'll kind of have no choice but to use the product rule. But when you see a function that says 5x times x squared plus 7, you might think, oh, I might just distribute that first, rewrite the function. That often will make the derivative easier to take. Not always, but often. So I just distributed the 5x first. There it is distributed. And you'll notice I didn't put f prime equals because I've not taken the derivative yet. I just rewrote the function. I distributed the 5x. It's 5x cubed plus 35x. Now, if I take the derivative of that, just using rules I already knew, so this here is f prime of x. The derivative of 5x third is, in fact, 15x squared. And the derivative of 35x is just 35. And I did, in fact, get the same thing. So if it's an easy distributive property, it might be easier to distribute before using the product rule. But that is a product, and the product rule will absolutely work. The next example, we have no choice. The function is clearly a product. It is a function x times a function e to the x. I am still in the habit when I see a product of doing that. Like there's my first, there's my second, there's my f, and there's my g. So the derivative of this would be first times the derivative of the second plus second times the derivative of the first. So this would be f prime of x equals the first x, unchanged, times the derivative of the second. Fortunately, in this particular example, the derivative of the second, the derivative of e to the x is conveniently itself. So this is times e to the x. That's the first times the derivative of the second, plus the second, which is e to the x, unchanged, times the derivative of the first. And the derivative of x is just 1. Now, once we start using the product rule, and then we're going to learn the quotient rule, and we're going to learn something called the chain rule. These are how to take derivatives of kind of more confusing looking functions. A common question will be, how simplified do I need to make the derivative? And that's a tough question to answer. If this were the AP test and you were to leave it like that, that would be 100% correct. But if it were a multiple choice question, it very well might be simplified. And like in the last one, let me go back here. So the question could have been, should I have stopped there? And I would argue you could have stopped there, but you certainly, if it were a multiple choice question, you wouldn't stop there because that's not what the answer choice would look like. Same thing here. Another way to simplify things is to, if there's any common factors, just to pull them out. That's another very common way to simplify functions like this. So I could write this as f prime of x. I would argue those two terms, x e to the x and e to the x, have a common factor of e to the x. And if I take out that common factor, I think it's x plus 1. That's what that would look like on the AP test, like a multiple choice answer would, not that the line in purple is wrong, but one way to simplify things is to take out a common factor. And I realize I'm being kind of contradictory because over here, we're putting back in some common factor. We distributed that out to simplify it, whereas here we took out a common factor. So it's no perfect right or wrong which way is best, but be aware that taking out a common factor is it's a common practice. Okay. Next example. All right, here we have to keep track of a couple things. We have something minus something. This is, I'm going to erase this. This is wrong. This is not F and G. That's not what, if I'm thinking product rule, and I need to think product rule here, that's not what I'm thinking. I'm thinking that this first piece, the 2x cosine x, is a product rule. There's the first and there's the second. And then I have minus another term, so I have to just make sure that I just take the derivative of that separately. Okay. So here we go. Y prime equals. Before the minus sign, let's use the product rule. First times the derivative of the second plus the second times the derivative of the first. So the first is 2x. The second is the derivative of the second. I'm sorry, we want first times the derivative of the second. Now, you want to avoid a common mistake, listen carefully. The derivative of cosine of x, I know that you know, is negative sine x. And if you just write it like this, 2x and then times negative sine x, it sure looks like you wrote 2x minus sine x, which is absolutely not what we are doing. So you have to be real careful, and you have to use parentheses because it helps me keep track of what's going on. This is 2x times negative sine of x, and you got to be real careful about that. So that's the first times the derivative of the second. I'm still dealing with the blue product here, plus the second, which is the cosine of x, times the derivative of the first, and the derivative of 2x is just 2. Now I'm done with the product. Now the derivative of minus 2 sine x, that's not new. That's just minus 2 cosine of x. I should have maybe called that one green, and I could have called that one green. And there went my camera, sorry. Trying to get them to change the timer on my camera so it doesn't go off so quickly, but I don't have that kind of power. So now I might clean this up. Just so you know, the way you would see this, if it says 2x times negative sine of x, and it's not a minus sign, you see that as negative 2x sine of x. That's going to be the simplest way to see that. And these two terms, which I'll circle in red here, that appears to be 2 cosine of x minus 2 cosine of x. I believe they do in fact go away in this case. Look back at my answer here. Negative 2x sine of x. There you go. So those just happen to cancel out. So there's the derivative. So be aware of the product rule. I think I have 2 more examples. One is quick. The other one just shows you something that I'm trying to get you to figure out. Okay. All right. What about a function like 5x to the 4th? Obviously, you've known how to take the derivative of 5x to the 4th for a long time. This is not new. So if f of x equals 5x to the 4th, you know that f prime of x is just 20x cubed. That's not new. That's just the constant multiple rule. But if you were to say, hey, Mr. Null, and you'd say this if you were in my classroom with me, hey, Mr. Null, isn't that really a product? 5 times x to the 4th? Absolutely, it's a product. Could we use the product rule? Sure, we could. I'm here to tell you we don't need to, and we convince you that that's true. If we were to use the product rule, here we go. Now we're over here. F prime of x equals the first, which is 5, times the derivative of the second, and the derivative of x to the 4th is 4x cubed, plus the second, which is x to the 4th, times the derivative of the first. But the first is a constant, and the derivative of a constant is, in fact, 0. If I clean this up, I end up with 20x cubed plus 0. So you'll get the same answer. So the moral of that story is if it's just a constant times a function, while that is officially a product, you can just use the constant multiple rule. Now, if the product rule is wrong, we'll see the same thing with a quotient. We'll learn a quotient rule tomorrow. And if you're just dividing by a number, it's easier just to treat it as a constant, not a quotient. So just be aware of that. I want to do one more, just because there's one mistake that people make here. I just have to make up a problem here. So let's go with f of x equals 2x to the 3rd minus x sine of x. So here again, we have 2 things going on. We have a function minus a function. So we're going to take the 2 derivatives separately. And after that minus sign, that x sine x is in fact a product. So we have to think product rule here. So I might circle this in blue. Obviously, the derivative of that's just 6x squared. And then here is my product. And the reason we're doing this example is because of this minus sign right there. I'm trying to make it bold. We got to be real careful of that minus sign. So let's find the derivative of this. First, in blue, let's take the derivative of 2x to the 3rd. You can't forget the derivatives you already knew. The derivative of 2x to the 3rd is just 6x squared Now, putting that big minus sign here. Now I have a product. And if you just were to start start writing first derivative second plus second derivative first, which is, of course, the product rule, you have to keep track that you're subtracting the entire derivative of that. So I'm going to remind, whenever you're subtracting a product, throw a parentheses there. And now do first derivative second plus second derivative of the first, just like we now know the product rule. And then after you do that, make sure you distribute that minus sign. If that bold minus sign happened to be a plus sign, we wouldn't have these issues. It would just be first derivative of the second plus second derivative of the first. We wouldn't have to be so careful. But putting a minus sign before a product is so often missed. Like people just forget to handle minus sign correctly. So now let's product rule this x sine x. That's a product, x times sine x. So the product rule is first, which is x, times the derivative of the second. The derivative of sine x is cosine of x, plus the second, which is just sine of x, times the derivative of the first, which is just 1. If you stop there, nothing wrong with it. But the answer you'd probably see is just distributing the minus sign. I don't think you can compare them like terms to combine. But I think this would become 6x squared minus x cosine of x minus sine of x. And if you forget those big red parentheses, that purple minus sign you would have left as a plus without, and that would have been absolutely wrong. Just be real careful using the product rule. Excuse me. All right, so that's it for the product rule. You have homework assignment has only about 8 or 10 problems. There are some where you're just finding the derivative using the product rule. There are some where you're saying it says find the derivative and then find f prime of 5, just gives you some number. You know from lessons past that that just means take the derivative and then just evaluate it at a particular x value. Remember, when it says to find f prime of 5, that could say find the slope of the tangent line. It doesn't say that, but it could. And then the last couple ask you, like I said would happen often, to find the equation of a tangent line, where you take the derivative, plug in the x value, and evaluate it to get the slope, and then use point slope form to find the equation of the line. So having said all that, there is your homework assignment. Now, let me also clarify, I posted something about getting better at turning in late work, and it's now early Thursday morning, and I'm going to make this due Friday at 11:59. That's what I said I would do. I would give you a day and a half to get things done. PM, sorry, not AM. But I need you to know that tomorrow there will be new notes. Like I don't have time to keep waiting for that second day to come and go, and then after that, post the new material. We're on pace currently to not get far enough through the curriculum. So tomorrow there will be a new lesson. It'll be the quotient rule. There'll be a new assignment. It'll be due probably Sunday night. So while I'm giving you a day and a half to do these assignments, I'm encouraging you to stay on top of things, because the pace is not going to get slow. Actually, the pace has to quicken a little bit in order for us to get where we need to go. So having said that, have a great Thursday.